Our story begins at the very start of time itself. Scientists call this moment the Big Bang, not an explosion in space, but the birth of space itself. Imagine all the energy and matter in the universe squeezed into a point smaller than an atom, hot, dense, and full of potential. The universe began to expand rapidly, a period known as inflation. As it expanded and cooled, the fundamental forces separated, and energy transformed into matter. The first elements, hydrogen and helium, were forged in this early universe. After about 380,000 years, atoms formed and the universe became transparent. The ancient light from that moment, the cosmic microwave background, still travels through space today. Every atom, every star, every planet traces its origin back to the Big Bang. Our cosmic story starts here. How do we know the Big Bang happened nearly 14 billion years ago? The evidence is written in the cosmos itself. In the 1920s, Edwin Hubble observed that distant galaxies are moving away from us. The universe is expanding. If everything is moving apart now, it must have once been much closer together. This led to the prediction of a leftover afterglow from the Big Bang. In the 1960s, Arno Penzias and Robert Wilson discovered this ancient radiation, the cosmic microwave background, or CMB. The CMB is like a baby picture of the universe, showing us what it looked like just 380,000 years after the Big Bang. Tiny temperature variations in the CMB mark the seeds of cosmic structure, where galaxies would eventually form. The Big Bang theory also predicts the amounts of hydrogen and helium in the universe. Observations of the oldest stars and distant gas clouds match these predictions exactly. The remarkable agreement between theory and observation gives us confidence in the Big Bang. The story of our universe's birth is not just a guess. It's built on solid evidence. The expanding universe, the CMB, and the abundance of elements all point to a single powerful origin. Our understanding of the cosmos is grounded in what we can see, measure, and test. The Big Bang remains the best explanation for how everything began. Since its fiery birth, the universe has never stopped changing. Its most dramatic change is continuous expansion, like raisins moving apart in rising bread dough. Galaxies aren't flying through space. Space itself is stretching, carrying them along. For decades, scientists thought gravity might slow this expansion, maybe even stop it. But in the late 1990s, astronomers studying distant supernovae made a shocking discovery. The expansion is speeding up. Instead of slowing, the universe is accelerating, driven by a mysterious force called dark energy. Dark energy acts like anti-gravity, pushing galaxies apart faster and faster. It now makes up about 70% of the universe's total energy. This discovery changed everything we thought we knew about the cosmos. The fate of the universe is now tied to this invisible force. Dark energy's true nature remains one of the greatest mysteries in science. Its presence will determine how the universe evolves and how it might end. The universe's story is one of constant motion, shaped by forces we're only beginning to understand. Our journey through space and time is far from over. How will the universe's story end? It depends on the battle between gravity and dark energy. Scientists once imagined three main endings: the Big Crunch, the Big Freeze, and the Big Rip. In the Big Crunch, gravity wins, the universe collapses, and everything ends in a fiery reversal of the Big Bang. The Big Freeze, or heat death, sees the universe expand forever, growing cold and dark as stars burn out and galaxies fade. The Big Rip, driven by ever-stronger dark energy, tears apart galaxies, stars, planets, even atoms themselves. Today, the Big Freeze seems most likely endless expansion, growing emptier and colder over time. But our understanding of dark energy is still new. If its nature changes, the universe's fate could be very different. Each scenario offers a different vision: dramatic collapse, slow fade, or violent end. The universe's destiny is still an open question. What we know is that dark energy now dominates, pushing the cosmos toward a cold, lonely future. Yet the final chapter is unwritten. The universe's end may hold surprises we can't yet imagine. Our quest to understand it continues. The story is not yet finished. If the universe ends, could a new one begin? This is the idea of a cyclical universe, endless cycles of birth, death and rebirth. Some scientists wonder if our Big Bang was triggered by the collapse of a previous universe. In this view, each universe is a link in an infinite chain, each with its own Big Bang and fate. The laws of physics might change with each cycle or remain the same. The end of one universe could set the stage for the next. This challenges our idea of a single beginning, suggesting the cosmos could be eternal. While we have no proof, the possibility of a cosmic cycle is one of the most exciting ideas in modern cosmology. It transforms our story from a single event to an endless, beautiful dance. For a cyclical universe, there must be a way for one universe to give rise to the next. The Big Crunch is one such idea. The universe collapses, becoming hot and dense, then bounces back in a new Big Bang. All matter and energy would be recycled, forming a new cosmos. However, the discovery of dark energy makes a future collapse unlikely. Dark energy's push seems stronger than gravity's pull, making a Big Crunch improbable. Still, the idea highlights the cosmic tension between expansion and gravity. It raises deep questions about what happens when everything is compressed into a single point. To truly understand, we need new physics, perhaps a theory of quantum gravity. If a Big Crunch is unlikely, could the universe be reborn another way? The Big Bounce theory suggests the universe never shrinks to a point, but rebounds from a minimum size. Quantum gravity models propose a cosmic spring squeezed, but never to nothing, then bouncing back. Even in a cold, empty universe, quantum fluctuations might trigger a new Big Bang, a rebirth from near nothingness. These ideas are speculative, but they offer hope for a universe that renews itself. The Big Bang may not have been the first, just the latest in a series of cosmic cycles. Scientists search for clues in the cosmic microwave background, hoping to find evidence of a universe before our own. The possibility of a cosmic rebirth keeps our curiosity alive. The universe may be more eternal and mysterious than we ever imagined. Our search for answers continues at the very edge of knowledge. Will there be a second Big Bang? We don't know. We've uncovered a remarkable story, from the Big Bang to today's accelerating expansion. Evidence points to a universe headed for endless expansion, not a cycle. But our knowledge is incomplete. A new physics could change everything. Theories like the Big Bounce remind us that cosmic rebirth is possible. Great mysteries remain. What is dark energy? What happens at a singularity? We are explorers, mapping the edge of the unknown, driven by wonder and curiosity. The story of the cosmos is far from over.